Hello everybody, today we'll be doing maximal network rank. There is an infrastructure of n cities with some number of roads connecting these cities. Each road has a connection between A and B, indicating the bidirectional road between cities A and B. The network rank of two different cities is defined as the total of the number of direct connected roads to either city. If a road is directly connected to both cities, it is only counted once. The maximal network rank of the infrastructure is the maximum network rank of all pairs of different cities. Given the integer n and the array roads, return the maximal network rank of the entire infrastructure. Here we have an example where we have 4 total cities and we have 4 roads. As you can see here, we have a maximum connection of 4. The reason being, we can have 0 connect to 1 and 3. So that's 2 connections for 0. So 0 connects to 1 and 3, like a set. And 1 connects to 2 and 3. And so that's a total of 4 cities that can be connected together. As you can see here, in the next example, let's talk about through all the happy cases and all the edge cases. Let's take a look at the second one. So here's what we got. We got 0 pointing to 1 and 3, 1 pointing to 2 and 3, and then there's 2 pointing to 3 and 4. Okay, so 0 points to 1 and 3, 1 points to 2 and 3, and 2 points to 3 and 4. As you can see, 3 actually has a connection to 1, 2, and 4. 4 has a connection to 2 only. That's when you have to do this bidirectionally to get all of these items in one. So there's a total of 5 connections because 3 connects to 3 cities, and you can pick and you can pick 1 to connect to 2 cities, or you can pick 2 to connect to 2 cities because you only count this connection once between 2 and 3. So if you pick 2 connections, like 2 and 3, right? This is connected to 1 as well. Sorry about that. So you pick 2. You're not counting 6. You're counting only the connection that are different between that when they're connected to each other, you only count that connection once. So if this item is in this item, then we should only count it once. Okay, let's check out this last example here, and let's think about some edge cases afterwards. So here's a connection of 8. So 0, 1, 2, 3, 4, 5, 6, 7. Those are 8 different items. So 0, 1. So 0's in 1. So we do this bidirectionally. 1 and 2. So 2 is here. So we do a 0 here. And sorry. That's 1 and 2. My bad. That's 1 and 2. And 1. Okay, done with that. Check. 2 and 3. So there's a 3 here. There's a 2 here. Check. 2 and 4. So there's a 4 here. There's a 2 here. Check. 5 and 6. So 6 here. 5 here. Check. 5 and 7. So there's a 5 here. And the 7 here. From what we can see from this item here, we have this is a total of 5, and we have 5. Perfect. What are the edge cases? So the maximum n and the minimum n is 100. So we're limited to at most 2. N equals 2 is our basic, and roads can be 0. So there can be 0 roads. What will happen if there are 0 roads? We can check both items, so 0 and 1, and they have no connections to any other. So we should return a total of 0. So I think we should take care of that. Also, what else can we think about between these roads? If there is one connection, let's say there's one connection, right? Let's for a different example. Then what we have here is a connection between 0 and 1 and 0. So there's one connection. That's it. We can't have any more because, I mean, even if you do more connections, what are you going to connect? Nothing else, right? I mean, you can have 1 and 0, but that's basically the same. And there's going to be no difference between these here. There's not going to be any change between in our collection of dictionaries with sets. So with that, let's get to matching. Our match is going to be using a dictionary set to manage all connections. And we're going to use a combination to get the combination of two cities and get the most amount of connections. So the plan, well, before we make a plan, our time and space complexity, I'm predicting, is going to be O of n squared, because the reason is because we will need to be going through all the combinations, and for combinations between, it's going to be, if you have 8 items, it's going to be 8 times 7 times 6 times 4 times 3 times 2 times 1, and that's going to be basically n times n divided by 2, and that's n squared. And when you're talking about space, if each item is connected to any other item, what you have here, let's say we have these 4 connections here, and let's say all of them are connected, right? What happens here is that you have basically 1, 2, 3, 4, n minus 1 for every single item. So this is going to be 0, like 2, 3, and 4. And this is going to be like 1 to 0, 1, 0, 1, 3, 4, and so on and so forth. And you will have n times n minus 1 items. So that's going to be O of n squared. Because storing n times n minus 1 items, because combinations of 2 cities. Okay, so with that, time and space and the match, we can start planning now. We're going to create a dictionary to map out the connections from each city. And 2, what we're going to do is go through the combination of 2 cities, and get the max connections. Okay, and lastly, what we're going to do is return max connections. With that, I think we're ready to implement. Let's comment out all of these items here. And let's get it. So implement. Oh, it's up there. Implement's up there. My bad. Ha. Okay. So what we do is we need to create our dictionary. Let's call it our graph. And default dict set. So for road in roads, graph of road 0 dot add road 1, and graph of road 1 dot add road 0. So I think there's a better way of writing this. So we can do city 1 and city 2. And that way, I think we have a little, I mean, it looks a lot better than this. So I'm going to clean up this code immediately because it looks kind of funky, and I think this is a better way of writing it. So that's that. Now we're done with step 1. We created a dictionary and mapped out the city one to each other as we've done manually, and we're now done doing with code. So let's do all the combinations. How do we do all the combinations? Well, there is a tool called iter tool, and you do dot combinations of our item, which is graph keys, and we're going to combine 2 of them. And with that, we're going to set for city 1 and city 2 in combinations. So we're going to get the combination of every 2 cities that are possible in our graph. There is one thing that I am thinking about, and those are all the cities that don't have any roads to them, n, right? What happens if we don't have any cities? So if they don't have any combinations, so we do need to make a default when that is 0, and so basically we need a for loop for city in n, range n, graph at n should exist. But I don't think that's a problem because we have default dict, so it should be fine. Okay, so let's complete this problem where we need to add the combination of 2 cities and reduce by 1 if they are in each other's set. So has repeated connection equals 1 if city 1 in graph of city 2, else 0. And what we're going to do is get the connections. City 1 connections is equal to length of graph of city 1, and city 2 connections is equal to length of graph of city 2. And we're going to get the max, right? So max connections is equal to 0 at this point. So max connections is equal to the max between max connections. And city 1 connections plus city 2 connections minus has the repeat connection. Has repeat connection means like it's a Boolean, but repeat connection is we're going to subtract that if there is one. Then we're going to return max connections. So with that, we can check the code to see if it works. That's a review process, and let's see where we go from there. Okay, look, everything looks good for 4. Let's test the test cases that we need to test for, and that's 2, and we have 0 items. That should return 0. And there was the other test case where we should return 1 as well. So there are 0 items. And now there is 1 connection here. It should be 1 because there's only 1 connection between the 2. And we should repeat this twice to see if we are if it handles all the edge cases that we threw at it. And so we're going to swap this between 1 and 0. And let's run that code as well. And with that, I think we have solved this problem. Oh! Yes. Well, it looks like the number of roads is n times n minus 1 divided by 2, and we can't have more roads than the number of cities that we have. So that's fine. That's an invalid input, and we don't have to handle that. But we can handle this. So with that, I think we have solved this problem. If there is, let's think about the evaluation now, and maybe we can talk about some better code in the comment section below. If you have any code that you would like to share, please comment or share a video. I would love to see it. Let's all learn together and maybe learn something new. So here's our evaluation. Again, it is, let's confirm if the time is O of n, n squared, because of combination of two cities, and that's yes. Here's the combination of two cities. It's going to be n squared. For the two cities in the roads, if there are those number of roads, that number of roads in the cities, it would be n squared as well, because n times n minus 1 items in the roads. So that would be both our time and space complexity. If also if roads is n times n minus 1 roads. Well, the maximum is n times n minus 1 divided by 2, but that also means that we connected all, so it's not. So it's n times n minus divided by 2. Still, that is still n squared. Also, road is maximum. So those are two ways that it can be n squared. And we have the storing of the n times n minus 1 items. That's possible with our graphs, so that's n squared as well. So it confirms our time and space complexity. With that, we have completed the problem in very few lines of code. We could shrink the number of lines of code here, right? We could shrink the number of lines of code, but that would make the code harder to read. But this tells you exactly what we're getting, the connections of city 1 and city 2 connections, and adding them all together, it kind of like reads better. So the next reader can read it better. And we talk about the repeat connection. There has been a repeat connection, and the repeat connection there's one repeat connection or no repeat connections. So that way we can share the code with the next reader more easily without commenting. Otherwise, we could comment the code, but I don't deem this complex enough to warrant that. Maybe you can make a suggestion why we should comment the code. Maybe we can comment the code here. We can just copy our plan here. We can create map and move this line down as well, and we can comment the code this way. That is one way we can comment the code, and this is our second comment as well. So those are our two comments. How about here? Find repeat connection. And the problem with commenting is that when you comment and when you change code, every time you change code, you also have to change the comment. So that's kind of annoying. So that's why sometimes you want to write code that just reads better so that you don't have to comment as much. But sometimes you can't be helped, and you do need to comment more. Let me know in the comments below to see whether we should comment more or comment less. And that's it. I'll see you in the next one.